Okay, so I'm going to try and undo the damage I did. That's the sound of my hot air gun starting up. I'm going to liberally coat these MOSFETs with some resin, some flux, because that's a lesson I learned. You need a lot of flux, because it's what helps the whole package heat up enough to come off. So I'm just going to goop it on there. You can always clean it off afterwards. Pardon my sniffles. It is kind of cold season here in Toronto. So my plan is to heat that up a fair amount and see if I can't get it to come off easily. Just lowering my bench light so that I can have it nice and close. Okay, the iron is Chinese and it's 700 degrees apparently, which I don't believe, but it might be. So let's work quickly. So I'm aiming directly down at the parts so that I don't heat up other components very much. Also, apparently a problem with the way these are built intentionally, they absorb a lot of heat, and all that heat goes elsewhere on the board before it actually heats up the components. I'm starting to see the glow. Is it hot enough to move? No, not yet. Because I should just be able to touch it and it'll move like butter. There we go. Now it's one component off. I'm taking both MOSFETs off, and then I'm going to test continuity. I want to make sure that there's no short circuits anymore. So we need to remove these guys too. I'm going to cover them. See how that melts right away? It's still hot, so that's good. It's going to make this one a little bit easier. I just need the points. I don't need the to super push. Should just come right off. And the goal here is disconnecting the power rails so that I can see if it makes a difference to the continuity. Because what I was seeing was, oh, come off there. What I was seeing was a short, basically. I don't want to see a short. So that's 2 down, 1 to go. One thing you might notice if you've seen the motherboard of the Xbox One original is that the S has fewer rails going to the APU. And yet it has a newer generation APU that has a smaller die, which should make it use less power. But you would think they wouldn't have cheaped out like that, but they did. I think it's cheaping out, but it might have been a design change because, you know, with these MOSFETs, that's probably within spec. But the problem with these little tiny MOSFETs that let 78 watts of power through them is that they're probably going to wear out really quick. There was no way this board was going to last like 5 years or 10 years or whatever. UHD video recording can up. So recording so close to the heat gun is actually overheating the camera. So I had to do this quickly and I had to restart. Okay, so that's it. I can let the board cool down and I can start testing it before it cools down actually and see if there's still a short. Oops, I want it in beep mode. That way I could hear it. So this should not connect to ground, and it does. This does not. It's over limit. Oh, it's over limit. So the problem is here. The problem is at these big MOSFETs. So I wonder if one of the other ones on the board is causing the short. Okay, so this MOSFET connects down to this resistor and into this input here of this tiny, tiny MOSFET, I think. Yeah, this wee little MOSFET. Or this wee little, I think it's a gate. It connects. Why is that grounded out? That's the mystery I need to find out now. So I'm going to put this video up on Element 14 and ask some of the smart guys there if they can help me out. Smart girls, smart people. Thank you very much. I almost forgot to show you the fun part. Little capful, well not even a capful, a little dab of isopropyl alcohol on a toothbrush. Let's clean that right off. Shaky camera and all. Get that flux off of there. That way you can be sure. What I'm also going to do, clean off these MOSFETs because I'm going to put them in a little package and keep them. I mean, some of them might still be perfectly good. All of them might be perfectly good. There could be, the short could be somewhere else. But we're narrowing things down now. I'm still probably going to buy all new ones because they cost like, you know, $1.30 a piece or something, even if you buy them one at a time. If you buy like 10, it's not much cheaper. I think it's a few cents cheaper, but you know. Yeah. Costs you not much for a handful of those guys. So yeah, cleaning up's important. The isopropyl should just evaporate away. And leave everything nice and clean. The next thing, I guess, would be to put the alcohol away and test the continuity through the MOSFETs. Although I think the voltage to trigger the MOSFET is very low, so I think the multimeter can actually trip it off. Let's go back to, well, there is a diode mode, a diode test. So I think, is this, it is this pin that is the gate pin. So 9 mega ohms. This is the gate pin. And this is the drain pin. Like 200 kilo ohms. I think this thing works. I think these MOSFETs are okay. These MOSFETs. Little tiny MOSFETs. Alright, further investigation is required, but I think those parts are actually fine. So again, going from this pin to ground, it's 1. It's always great when you're recording 4K video that your device decides to run updates. That's always handy. So again, I was testing, so this is MEMIO. Ohms to memory, 1.5 ohms to ground. 0.6, 1.5. So I wonder if these are fine, if these MOSFETs are fine, and maybe the problem is these poor little capacitors. This one got cooked. It's a little discolored. More investigations required. I don't know if I want to take any more parts off this thing tonight. I'm going to post these results and see what everyone has to say. All right, I'm too curious. So one more check. These are all the capacitors, and I want to see if they are what's causing the ground. Huh. How am I going to do this? Okay, that's not working. Just heating everything up and not doing anything. All right. I want to see a 1980s relic. This thing. It's coming loose. It's nice and hot on the other side. God damn, that's hot. Do I not have pliers? I don't. This is awkward. It's not the first time I've said that in my life. Okay, so we are slowly deconstructing this thing, one part at a time. Oh ho ho! Oh, 1.4 ohms. So it's still the same. The capacitors had nothing to do with it. Let me grab those capacitors. I wonder if they're fine. Capacitance tester. They might be perfectly fine. This is really perplexing. It might be one of the really tiny components then. Oh, where'd that screw fall? Get back here. Okay, so capacitance test. This is negative, this is positive, and I just dropped it. So negative. Oh, come on. This would be easier if I used the clamp ends. I probably should just grab that. Come on. It's not 4 nanofarads. Either with that or this is blown. Cheap this set is. A hold peak. They give you crimped alligator clips that are supposed to be able to fit the ends of this, but I don't think they fit. Nope. I think you're supposed to get different ends with it too, but they gave me the wrong ones. Okay, let's give this another try. Testing. 790. So that's a bit low, but it'll probably raise. Yeah, 799. They're supposed to be 820, I think. Yeah, 820. 819, I'll take it. That one's okay. It's still well within spec. So let's try this one. No, we need to polarity right, otherwise we'll screw it up. .904 farads. Okay. Come on. 851. Seems a bit high. Might be because it's hot. No, stop it. .857. Might be the capacitance of my fingers that are adding to this too, because I'm having to use my fingers to hold this in place. .923. So that seems a bit high, but they're definitely not dead. These are both connected. Somehow the drain, or sorry, the gate here is connected. It comes down to this pin, which is connected. That's not. So all of that's connected. The gate here is not connected. These drain pins are connected. So yeah, this whole side's not connected, which is cool, to ground. Oops, I'm touching that. It's funny. Is it this pin? Yeah, it's this pin maybe that it's coming down to. But these other pins, which are the drain for that little MOSFET, this little guy anyway. They all seem to be connected to this area. See, everything is grounded out, and I don't know what to look at.